Assalamualaikum and good day. Welcome to the Structural Mechanics CMA 412. For this video, we're going to cover on the general overview on structural behavior with me, Ms. Huda. At the end of this lecture, the students should be able to understand what is structure and understand types of structural forces and loads. What is structure? The structure of a building is the part which is responsible for maintaining the shape of the building under the influence of forces, loads, and other environmental factors to which it is subjected. It is important that the structure does not fall down, break, or deform to an unacceptable degree when subjected to loads or forces. There are other objects apart from building that have the structure element. For example, we have tree, which have branch, twig, trunk, and finally the root that made it a structure. And we have human, which the bones or the skeleton is the structure of the human. And how about car? The body of the car and also the tires actually that become the structure of the car. Within the context of built environment, the term structure refers to anything that is constructed or built from different interrelated parts with a fixed location on the ground. The term structure can also be used to refer to any body of connected part that is designed to bear loads even if it is not intended to be occupied by people. The study of structure involves the analysis of the forces and stresses occurring within the structure and the design of suitable components to cater such forces and stresses. For example, we have the structural components that may include the steel beams. This is the example of the beams, columns, roof trusses and space frames, reinforced concrete beams, columns, slab retaining walls and foundation, timber joists, column, glutenated beams and roof trusses, masonry walls and columns. The basic foundation of a structure is to transmit loads from the position application of the load to the point of support, thus two foundations in the ground. Any structure must satisfy the following criteria. Firstly, it is aesthetic, that the structure must look nice. Economy, it must not cost more than the client can afford, which is if you get it less, then it is more possible. Easy of maintenance. Durable, which means that the material used must be resistant to corrosion, spalling, chemical attack, rot or insect attack, and also must durable and resist from fire. Therefore, in order to ensure that the structure behaves in this way, it is necessary to develop an understanding and awareness of how the structure works. When designing for building structure, we must consider the limit state, where there are two of it, ultimate limit state and serviceability limit state. Ultimate limit state is a structure must carry the expected load without collapsing as a whole or part. For example, some of the ultimate limit state for steel to be considered are strength, stability, fracture due to fatigue, and brittle failure. It varies depends on the material. Safety in this respect depends on two factors. First, the loading that the structure is designed to carry has been correctly assessed, and the strength of material used in the structure has not deteriorated. Secondly, the serviceability limit state. A structure should not deform unduly under effects of deflection, cracking, and vibration. A structure must be designed in a way that it does not deflect or crack unduly in use. It is important that the deflection and cracking are kept within a certain limits. Excessive deflection does not necessarily mean that the floor is about to collapse, for example. But because it may lead to such concerns, deflection must be controlled or kept within a certain limit. This also depends on the material. For example, we have a steel structure. Some of the serviceability limit states to consider are deflection, corrosion, and durability, and also the fire protection. Types of building structure. From the top, we have roof trusses. Roof, it protects people and equipment in a building from weather. And the roof truss will support and transmit the load from the roof. Next here, we have roof beam. In building, it is necessary to support floors or walls or roof without any interruption or division of the space below. A horizontal element called beam will be used. A beam transmits the load it supports to column or walls at the beam's end. Apart from roof beam, we have upper floor beam that's supporting the upper floor and ground beam supporting the ground level. Next, we have column. A column is a vertical load-bearing element which usually supports beam and other columns above. It can also call pillars, poles, or posts. We also have slab, which provide support for occupants, furniture, and equipment in a building. Floor and upper level of building are always suspended, which means that they span between supporting wall or beams. Ground floor slab may sit directly on the ground beneath. We also have foundation here. Lastly, it represents the interface between the building structure and the ground beneath. A foundation transmits all the loads from the building into the ground in such a way that settlement of building is limited and failure of the underlying soil is avoided. And maybe kita pun boleh ada arch here. Is an arch. An arch is an opening in a structure that is curved on top and designed to distribute weight. And in this case, the weight comes from the roof. Fundamental purpose of building structure: to transmit loads from the point of application to the point of support, and finally through the foundation under the ground level. The structure must be capable to carry the loads and carefully designed to avoid the building from collapse. Types of loads. We have 4 types. First, dead load, live load, wind load, and seismic load. We're going to look at the dead load. It's a static load, which means that the load tu tak boleh bergerak lah. Loads that are permanent and stationary. Loads are transferred to structure throughout the lifespan. Sources of the load are self-weight of the structural members. For example, the walls, the beams, the columns, the foundations. And next, the life load. It is a dynamic load, which means that dia berubah-ubah. Also known as imposed loads. Loads that are movable. The amounts keep on changing from time to time sebab dia boleh bergerak, jadi dia akan berubah-ubah. For example, the occupants, furniture, plumbing, electrical appliances, snow, rain, and many others. Number 3, we have wind load. Wind loads can be applied by the movement of air relative to a structure. This is important for tall building, the use of lighter materials and the use of shapes that may affect the flow of air, typically roof forms. Sebab ada efek daripada angin. Where the dead weight of the structure is insufficient to resist wind loads, additional structure and fixings may be required differently to dead loads in structural design. So basically wind load ni pun kita panggil dia lateral load sebab dia bergerak horizontal. Next is seismic load. The internal forces acting on a building due to earthquake-induced ground motions act horizontally on each element of the structure and are proportional to their mass. This is the exercise that you can try. Look at the picture and categorize according to the dead load or life load as what you see in the picture. Structural behavior. Structures have many purposes ranging from strength to aesthetic beauty. The constants is the ability of a structure to support a given set of loads with an adequate factor of safety and carry this load throughout the structure to the ground. For example, what is structural behavior? Action of the loads, and because there is the load or weight, and there must be reaction. And all this study, we're going to study dalam structural analysis. And the structural language that you must know is 1. Force, 2. Reaction, 3. Stress, and 4. Moment. The first one, force. A force is an influence on an object that may cause movement. For example, the weight of people, furniture within a building cause a vertical downward force on the floor. Wind blowing against a building cause horizontal force on the external walls of the building. That is the example. Or perhaps if you look at the picture, when a man pushing the box upwards, there's a force that acting by the action of pushing. Reaction, the opposite pushing force with the same magnitude but different direction. If a man stands on a floor, the weight of the body will produce a downward force into the floor. The floor reacts to this by pushing upwards with a force of the same magnitude. This upward force is called reaction. Similarly, a wall or column supporting a beam will produce an outward reaction as response to the downward force that the beam transmits to the wall. And a foundation will produce an upwards reaction to the downward force in the column or wall that the foundation is supporting. That is reaction. Next is stress. It is an internal pressure. A heavy vehicle parked on the road is applying pressure to the road surface. The heavier the vehicle and the smaller the contact area between the vehicle tire and the road, the greater the pressure. Senang nak cakap macam ni lah. When there is a force transmitted pada sesuatu benda, doesn't matter a body or anything, a table for example, the body tends to change its shape. Apa-apa yang you letak pada satu objek tu try to resist daripada dia berubah bentuk. Dia tak nak berubah bentuk. Dia tak nak this deformation. Walaupun deformation ni kita tak nampak, but particles dekat dalam tu akan try to make up the body daripada transmit the force throughout the length and the section of the body. And then the fibers yang doing this work dikatakan dalam keadaan stress because they're trying to avoid the deformation. So it is internal pressure. Dia berada dalam keadaan stress lah. Lastly, moment, a turning effect produced by a force acting at a distance on an object. A moment is a turning effect. When you use a spanner to tighten a nut, for example, mechanically wind up, clock or turn the steering wheel on your car, you are applying a moment sebab dia berpusing. Okay, it's a turning effect. There's a formula for moment. Okay, moment is equal to force times distance. That will be all. Thank you. See you in the next video.